Chapter 20 of Edison, His Life and Inventions. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information, or to volunteer, please visit LibriVox.org. Recording by Melissa. Edison, His Life and Inventions by Frank Lewis Dyer and Thomas Commerfo Martin. Chapter 20 Edison Portland Cement. Few developments in recent years have been more striking than the general adoption of cement for structural purposes of all kinds in the United States, or than the increase in its manufacture here. As a material for the construction of office buildings, factories, and dwellings, it has lately enjoyed an extraordinary vogue, yet every indication is confirmatory of the belief that such use has barely begun. Various reasons may be cited, such as the growing scarcity of wood, once the favorite building material in many parts of the country, and the increasing dearness of brick and stone. The fact remains indisputable and demonstrated flatly by the statistics of production. In 1902 the American output of cement was placed at about 21 million barrels, valued at over $17 million. In 1907 the production is given as nearly 49 million barrels. Here, then, is an industry that doubled in 5 years. The average rate of industrial growth in the United States is 10% a year, or doubling every 10 years. It is a singular fact that electricity also so far exceeds the normal rate as to double in value and quantity of output and investment every 5 years. There is perhaps more than ordinary coincidence in the association of Edison with two such active departments of progress. As a purely manufacturing business, the general cement industry is one of even remote antiquity. And if Edison had entered into it merely as a commercial enterprise, by following paths already so well trodden, the fact would hardly have been worthy of even passing notice. It is not in his nature, however, to follow a beaten track except in regard to the recognition of basic principles. So that, while the manufacture of Edison Portland cement embraces the main essentials and familiar processes of cement making, such as crushing, drying, mixing, roasting, and grinding, his versatility and originality, as exemplified in the conception and introduction of some bold and revolutionary methods and devices, have resulted in raising his plant from the position of an outsider to the rank of the 5th largest producer in the United States, in the short space of 5 years after starting to manufacture. Long before his advent in cement production, Edison had held very pronounced views on the value of that material as the one which would obtain largely for future building purposes on account of its stability. More than 25 years ago one of the writers of this narrative heard him remark during a discussion on ancient buildings, "Wood will rot, stone will chip and crumble, bricks disintegrate, but a cement and iron structure is apparently indestructible. Look at some of the old Roman baths. They are as solid as when they were built." With such convictions and the vast fund of practical knowledge and experience he had gained at Edison in the crushing and manipulation of large masses of magnetic iron ore during the preceding 9 years, it is not surprising that on the homeward railway journey mentioned at the close of the preceding chapter, he should have decided to go into the manufacture of cement, especially in view of the enormous growth of its use for structural purposes during recent times. The field being a new one, Edison followed his usual course of reading up every page of authoritative literature on the subject, and seeking information from all quarters. In the meantime, while he was busy also with his new storage battery, Mr. Mallory, who had been hard at work on the cement plan, announced that he had completed arrangements for organizing a company with sufficient financial backing to carry on the business, concluding with the remark that it was now time to engage engineers to lay out the plant. Edison replied that he intended to do that himself, and invited Mr. Mallory to go with him to one of the drafting rooms on an upper floor of the laboratory. Here he placed a large sheet of paper on a drafting table, and immediately began to draw out a plan of the proposed works, continuing all day and away into the evening, when he finished, thus completing within the 24 hours the full layout of the entire plant as it was subsequently installed, and as it has substantially remained in practical use to this time. It will be granted that this was a remarkable engineering feat, especially in view of the fact that Edison was then a newcomer in the cement business, and also that if the plant were to be rebuilt today, no vital change would be desirable or necessary. In that one day's planning every part was considered and provided for, from the crusher to the packing house. From one end to the other, the distance over which the plant stretches in length is about half a mile, and through the various buildings spread over the space there passes, automatically, in course of treatment, a vast quantity of material resulting in the production of upward of 2¼ million pounds of finished cement every 24 hours, 7 days in the week. In that one day's designing, provision was made not only for all important parts, but minor details, such, for instance, as the carrying of all steam, water, and air pipes, and electrical conductors in a large subway running from one end of the plant to the other, and an oiling system for the entire works. This latter deserves special mention, not only because of its arrangement for thorough lubrication, but also on account of the resultant economy affecting the cost of manufacture. Edison has strong convictions on the liberal use of lubricants, but argued that in the ordinary oiling of machinery there is great waste, while much dirt is conveyed into the bearings. He therefore planned a system by which the 10,000 bearings in the plant are oiled automatically, requiring the services of only 2 men for the entire work. This is accomplished by a central pumping and filtering plant, and the return of the oil from all parts of the works by gravity. Every bearing is made rust-proof, and is provided with 2 interior pipes. One is above and the other below the bearing. The oil flows in through the upper pipe, and after lubricating the shaft, flows out through the lower pipe back to the pumping station, where any dirt is filtered out and the oil returned to circulation. While this system of oiling is not unique, it was the first instance of its adaptation on so large and complete a scale, and illustrates the far-sightedness of his plans. In connection with the adoption of this lubricating system, there occurred another instance of his knowledge of materials and intuitive insight into the nature of things. He thought that too frequent circulation of a comparatively small quantity of oil would, to some extent, impair its lubricating qualities, and requested his assistance to verify this opinion by consultation with competent authorities. On making inquiry of the engineers of the Standard Oil Company, his theory was fully sustained. Hence, provision was made for carrying a large stock of oil, and for giving a certain period of rest to that already used. A keen appreciation of ultimate success in the production of a fine quality of cement led Edison to provide very carefully in his original scheme for those details that he foresaw would become requisite, such, for instance, as ample stock capacity for raw materials and their automatic delivery in the various stages of manufacture, as well as mixing, weighing, and frequent sampling and analyzing during the progress through the mills. This provision even included the details of the packing house, and his perspicacity in this case is well sustained from the fact that 9 years afterward, in anticipation of building an additional packing house, the company sent a representative to various parts of the country to examine the systems used by manufacturers in the packing of large quantities of various staple commodities involving somewhat similar problems, and found that there was none better than that devised before the cement plant was started. Hence the order was given to build the new packing house on lines similar to those of the old one. Among the many innovations appearing in this plant are 2 that stand out in bold relief, as indicating the large scale by which Edison measures his ideas. One of these consists of the crushing and grinding machinery, and the other of the long kilns. In the preceding chapter there has been given a description of the giant rolls, by means of which great masses of rock, of which individual pieces may weigh 8 or more tons, are broken and reduced to about a 14-inch size. The economy of this is apparent when it is considered that in other cement plants the limit of crushing ability is 1 man size, that is, pieces not too large for 1 man to lift. The story of the kiln, as told by Mr. Mallory, is illustrative of Edison's tendency to upset tradition and make a radical departure from generally accepted ideas. When Edison first decided to go into the cement business, it was on the basis of his crushing rolls and air separation, and he had every expectation of installing duplicates of the kilns which were then in common use for burning cement. These kilns were usually made of boiler iron, riveted, and were about 60 feet long and 6 feet in diameter, and had a capacity of about 200 barrels of cement clinker in 24 hours. When the detail plans for our plant were being drawn, Mr. Edison and I figured over the coal capacity and coal economy of the 60-foot kiln, and each time thought that both could be materially bettered. After having gone over this matter several times, he said, "I believe I can make a kiln which will give an output of 100 barrels in 24 hours." Although I had then been closely associated with him for 10 years, and was accustomed to see him accomplish great things, I could not help feeling the improbability of his being able to jump into an old established industry, as a novice, and start by improving the heart of the production so as to increase its capacity 400%. When I pressed him for an explanation, he was unable to give any definite reasons, except that he felt positive it could be done. In this connection let me say that very many times I have heard Mr. Edison make predictions as to what a certain mechanical device ought to do in the way of output and costs, when his statements did not seem to be even among the possibilities. Subsequently, after more or less experience, these predictions have been verified, and I cannot help coming to the conclusion that he has a faculty, not possessed by the average mortal, of intuitively and correctly sizing up mechanical and commercial possibilities. But, returning to the kiln, Mr. Edison went to work immediately, and very soon completed the design of a new type, which was to be 150 feet long and 9 feet in diameter, made up in 10-foot sections of cast iron bolted together and arranged to be revolved on 15 bearings. He had a wooden model made, and studied it very carefully, through a series of experiments. These resulted so satisfactorily that this form was finally decided upon and ultimately installed as part of the plant. Well, for a year or so the kiln problem was a nightmare to me. When we started up the plant experimentally, and the long kiln was first put into operation, an output of about 400 barrels in 24 hours was obtained. Mr. Edison was more than disappointed at this result. His terse comment on my report was, "Rotten. Try it again." When we became a little more familiar with the operation of the kiln, we were able to get the output up to about 550 barrels, and a little later to 650 barrels per day. I would go down to Orange, and report with a great deal of satisfaction the increase in output, but Mr. Edison would apparently be very much disappointed, and often said to me that the trouble was not with the kiln, but with our method of operating it, and he would reiterate his first statement that it would make 1,000 barrels in 24 hours. Each time I would return to the plant with a determination to increase the output if possible, and we did increase it to 750, then to 850 barrels. Each time I reported these increases, Mr. Edison would still be disappointed. I said to him several times that if he was so sure the kiln would turn out 1,000 barrels in 24 hours, we would be very glad to have him tell us how to do it, and that we would run it in any way he directed. He replied that he did not know what it was that kept the output down, but he was just as confident as ever that the kiln would make 1,000 barrels per day, and that if he had time to work with and watch the kiln, it would not take him long to find out the reasons why. He had made a number of suggestions throughout these various trials, however, and as we continued to operate, we learned additional points in handling, and were able to get the output up to 900 barrels, then 1,000, and finally to over 1,100 barrels per day, thus more than realizing the prediction made by Mr. Edison before even the plans were drawn. It is only fair to say, however, that prolonged experience has led us to the conclusion that the maximum economy and continuous operation of these kilns is obtained by working them at a little less than their maximum capacity. It is interesting to note, in connection with the Edison type of kiln, that when the older cement manufacturers first learned of it, they ridiculed the idea universally, and were not slow to predict our early finish as cement manufacturers. The ultimate success of the kiln, however, proved their criticisms to be unwarranted. Once aware of its possibility, some of the cement manufacturers proceeded to avail themselves of the innovation, at first without Mr. Edison's consent, and today more than one-half of the Portland cement produced in this country is made in kilns of the Edison type. Old plants are lengthening their kilns wherever practicable, and no wide-awake manufacturer, building a modern plant, could afford to install other than these long kilns. This invention of Mr. Edison has been recognized by the larger cement manufacturers, and there is every prospect now that the entire trade will take licenses under his kiln patents. When he decided to go into the cement business, Edison was thoroughly awake to the fact that he was proposing to butt into an old established industry, in which the principal manufacturers were concerns of long standing. He appreciated fully its inherent difficulties, not only in manufacture, but also in the marketing of the product. These considerations, together with his long-settled principle of striving always to make the best, induced him at the outset to study methods of producing the highest quality of product. Thus he was led to originate innovations in processes, some of which had been preserved as trade secrets, but of the others there are two deserving special notice, namely, the accuracy of mixing and the fineness of grinding. In cement making, generally speaking, cement, rock, and limestone in the rough are mixed together in such relative quantities as may be determined upon in advance by chemical analysis. In many plants this mixture is made by barrow or load units, and may be more or less accurate. Rule-of-thumb methods are never acceptable to Edison, and he devised therefore a system of weighing each part of the mixture so that it would be correct to a pound, and even at that made the device foolproof, for as he observed to one of his associates, the man at the scales might get to thinking of the other fellow's best girl, so 50 or 100 pounds of rock, more or less, wouldn't make much difference to him. The Edison checking plan embraces two hoppers suspended above two platform scales, whose beams are electrically connected with a hopper closing device by means of needles dipping into mercury cups. The scales are set according to the chemist's weighing orders, and the material is fed into the scales from the hoppers. The instant the beam tips, the connection is broken, and the feed stops instantly, thus rendering it impossible to introduce any more material until the charge has been unloaded. The fine grinding of cement clinker is distinctly Edisonian in both origin and application. As has already been intimated, its author followed a thorough course of reading on the subject long before reaching the actual projection or installation of a plant, and he had found all authorities to agree on one important point, namely, that the value of cement depends upon the fineness to which it is ground. He also ascertained that in the trade the standard of fineness was that of 75% of the whole mass would pass through a 200 mesh screen. Having made some improvements in his grinding and screening apparatus, and believing that in the future engineers, builders, and contractors would eventually require a higher degree of fineness, he determined, in advance of manufacturing, to raise the standard 10 points, so that at least 75% of his product should pass through a 200 mesh screen. This was a bold step to be taken by a newcomer, but his judgment, backed by a full confidence and ability to live up to the standard, has been fully justified in its continued maintenance, despite the early incredulity of older manufacturers as to the possibility of attaining such a high degree of fineness. Footnote. For a proper understanding and full appreciation of the importance of fine grinding, it may be explained that Portland cement, as manufactured in the Lehigh Valley, is made from what is commonly spoken of as cement rock, with the addition of sufficient limestone to give the necessary amount of lime. The rock is broken down and then ground to a fineness of 80 to 90% through a 200 mesh screen. This ground material passes through kilns and comes out in clinker. This is ground, and that part of that finely ground clinker that will pass a 200 mesh screen is cement. The residue is still clinker. These coarse particles, or clinkers, absorb water very slowly, are practically inert, and have very feeble cementing properties. The residue on a 200 mesh screen is useless. End footnote. If Edison measured his happiness, as men often do, by merely commercial or pecuniary rewards of success, it would seem almost redundant to state that he has continued to manifest an intense interest in the cement plant. Ordinarily, his interest as an inventor wanes in proportion to the approach to mere commercialism. In other words, the keenness of his pleasure is in overcoming difficulties, rather than the mere piling up of a bank account. He is entirely sensible of the advantages arising from a good balance at the banker's, but that has not been the goal of his ambition. Hence, although his cement enterprise reached the commercial stage a long time ago, he has been firmly convinced of his own ability to devise still further improvements and economical processes of greater or less fundamental importance, and has, therefore, made a constant study of the problem as a whole and in all its parts. By means of frequent reports, aided by his remarkable memory, he keeps in as close touch with the plant as if he were there in person every day, and is thus enabled to suggest improvement in any particular detail. The engineering force has a great respect for the accuracy of his knowledge of every part of the plant, for he remembers the dimensions of details of every item of machinery, sometimes to the discomfiture of those who are around it every day. A noteworthy instance of Edison's memory occurred in connection with this cement plant. Some years ago, as its installation was nearing completion, he went up to look it over and satisfy himself as to what needed to be done. On the arrival of the train at 10:40 in the morning, he went to the mill, and with Mr. Mason, the general superintendent, started the crusher at one end and examined every detail all the way through to the packing house at the other end. He made neither notes nor memoranda, but the examination required all the day, which happened to be a Saturday. He took a train for home at 5:30 in the afternoon, and on arriving at his residence at Orange, got out some notebooks and began to write entirely from memory each item consecutively. He continued at this task all through Saturday night, and worked steadily on until Saturday afternoon, when he completed a list of nearly 600 items. The nature of this feat is more appreciable from the fact that a large number of changes included all the figures of new dimensions he had decided upon for some of the machinery throughout the plant. As the reader may have a natural curiosity to learn whether or not the list so made was practical, it may be stated that it was copied and sent up to the general superintendent with instructions to make the modifications suggested, and report by numbers as they were attended to. This was faithfully done, all the changes being made before the plant was put into operation. Subsequent experience has amply proven the value of Edison's prescience at this time. Although Edison's achievements in the way of improved processes and machinery have already made a deep impression in the cement industry, it is probable that this impression will become still more profoundly stamped upon it in the near future with the exploitation of his poured cement house. The broad problem which he sets himself was to provide handsome and practically indestructible detached houses, which could be taken by wage earners at very moderate monthly rentals. He turned this question over his mind for several years, and arrived at the conclusion that a house cast in one piece would be the answer. To produce such a house involved the overcoming of many engineering and other technical difficulties. These he attacked vigorously and disposed of patiently one by one. In this connection a short anecdote may be quoted from Edison as indicative of one of the influences turning his thoughts in this direction. In the story of the ore milling work, it has been noted that the plant was shut down owing to the competition of the cheap ore from the Mesaba range. Edison says, "When I shut down, the insurance companies canceled my insurance. I asked the reason why. Oh, they said, this thing is a failure. The moral risk is too high. All right, I am glad to hear it. I will now construct buildings that won't have any moral risk." I determined to go into the Portland cement business. I organized a company and started cement works, which have now been running successfully for several years. I had so perfected the machinery in trying to get my ore costs down that the making of cheap cement was an easy matter to me. I built these works entirely of concrete and steel, so that there is not a wagon load of lumber in them, and so that the insurance companies would not have any possibility of having any moral risk. Since that time I have put up numerous factory buildings, all of steel and concrete, without any combustible whatever about them, to avoid this moral risk. I am carrying further the application of this idea in building private houses for poor people, in which there will be no moral risk at all, nothing whatever to burn, not even by lightning. As a casting necessitates a mold, together with a mixture sufficiently fluid in its nature to fill all of the interstices completely, Edison devoted much attention to an extensive series of experiments for producing a free-flowing combination of necessary materials. His proposition was against all precedent. All expert testimony pointed to the fact that a mixture of concrete, cement, sand, crushed stone, and water could not be made to flow freely to the smallest parts of an intricate set of molds, that the heavy parts of the mixture could not be held in suspension, but would separate out by gravity, and make an unevenly balanced structure, that the surface would be full of imperfections, etc. Undeterred by the unanimity of adverse opinions, however, he pursued his investigations with the thorough minuteness that characterizes all his laboratory work, and in due time produced a mixture which on elaborate test overcame all objections and answered the complex requirements perfectly, including the making of a surface smooth, even, and entirely waterproof. All the other engineering problems have received study in like manner, and have been overcome, until at the present writing the whole question is practically solved and has been reduced to actual practice. The Edison poured or cast cement house may be reckoned as a reality. The general scheme, briefly outlined, is to prepare a model and plans of the house to be cast, and then to design a set of molds and sections of convenient size. When all is ready, these molds, which are of cast iron with smooth interior surfaces, are taken to the place where the house is to be erected. Here there has been provided a solid concrete cellar floor, technically called footing. The molds are then locked together so that they rest on this footing. Hundreds of pieces are necessary for the complete set. When they have been completely assembled, there will be a hollow space in the interior, representing the shape of the house. Reinforcing rods are also placed in the molds, to be left behind in the finished house. Next comes the pouring of the concrete mixture into this form. Large mechanical mixers are used, and as it is made, the mixture is dumped into tanks, from which it is conveyed to a distributing tank on the top or roof of the form. From this tank a large number of open troughs or pipes lead the mixture to various openings in the roof, whence it flows down and fills all parts of the mold from the footing in the basement until it overflows at the tip of the roof. The pouring of the entire house is accomplished in about 6 hours, and then the molds are left undisturbed for 6 days, in order that the concrete may set and harden. After that time the work of taking away the molds is begun. This requires 3 or 4 days. When the molds are taken away, an entire house is disclosed, cast in one piece, from cellar to tip of roof, complete with floors, interior walls, stairways, bath and laundry tubs, electric wire conduits, gas, water, and heating pipes. No plaster is used anywhere, but the exterior and interior walls are smooth, and may be painted or tinted if desired. All that is now necessary is to put in the windows, doors, heater, and lighting fixtures, and to connect up the plumbing and heating arrangements, thus making the house ready for occupancy. As these wooden molds are not ephemeral, like the wooden framing now used in cement construction, but of practically illimitable life, it is obvious that they can be used a great number of times. A complete set of molds will cost approximately $25,000, while the necessary plant will cost about $15,000 more. It is proposed to work as a unit plant for successful operation at least 6 sets of molds, to keep the men busy and the machinery going. Anyone, with a sheet of paper, can ascertain the yearly interest on the investment as a fixed charge to be assessed against each house, on the basis that 144 houses can be built in a year with the battery of 6 sets of molds. Putting the sum at $175,000 and the interest at 6% on the cost of the molds and 4% for breakage, together with 6% interest and 15% depreciation on machinery, the plant charge is approximately $140 per house. It does not require a particularly acute prophetic vision to see flower towns of poured houses going up in whole suburbs outside all our chief centers of population. Edison's conception of the working man's ideal house has been a broad one from the very start. He was not content merely to provide a roomy, moderately priced house that should be fireproof, waterproof, and vermin-proof, and practically indestructible, but has been solicitous to get away from the idea of a plain packing-box type. He has also provided for ornamentation of a high class in designing the details of the structure. As he expressed it, "We will give the working man and his family ornamentation in their house. They deserve it, and besides, it costs no more after the pattern is made, to give decorative effects than it would be to make everything plain." The plans have provided for a type of house that would cost not far from $30,000 if built from cut stone. He gave to Messrs. Mann and McNally, architects, New York, his idea of the type of house he wanted. On receiving these plans he changed them considerably, and built a model. After making many more changes in this while in the pattern shop, he produced a house satisfactory to himself. This one-family house has a floor plan 25 by 30 feet, and is 3 stories high. The first floor is divided off into 2 large rooms, parlor and living room, and the upper floors contain 4 large bedrooms, a roomy bathroom, and wide halls. The front porch extends 8 feet, and the back porch 3 feet. A cellar 7½ feet high extends under the whole house, and will contain the boiler, wash-tubs, and coal bunker. It is intended that the house shall be built on lots 40 by 60 feet, giving a lawn and a small garden. It is contemplated that these houses shall be built in industrial communities, where they can be put up in groups of several hundred. If erected in this manner, and by an operator buying his materials in large quantities, Edison believes that these houses can be erected complete, including heating apparatus and plumbing, for $1,200 each. This figure would also rest on the basis of using in the mixture the gravel excavated on the site. Comment has been made by persons of artistic taste on the monotony of a cluster of houses exactly alike in appearance, but this criticism has been anticipated, and the molds are so made as to be capable of permutations of arrangement. Thus it will be possible to introduce almost endless changes in the style of house by variation of the same set of molds. For more than 40 years Edison was avowedly an inventor for purely commercial purposes. But within the last 2 years he decided to retire from that field so far as new inventions were concerned, and to devote himself to scientific research and experiment in the leisure hours that might remain after continuing to improve his existing devices. But although the poured cement house was planned during the commercial period, the spirit in which it was conceived arose out of an earnest desire to place within the reach of the wage earner an opportunity to better his physical, pecuniary, and mental conditions, in so far as that could be done through the medium of hygienic and beautiful homes at moderate rentals. From the first, Edison had declared that it was not his intention to benefit pecuniarily through the exploitation of this project. Having actually demonstrated the practicability and feasibility of his plans, he will allow reasonable concerns to carry themselves into practice under such limitations as may be necessary to sustain the basic object, but without any payment to him except for the actual expense incurred. The hypercritical may cavil and say that, as a manufacturer of cement, Edison will be benefited. True, but as any good Portland cement can be used, and no restrictions as to source of supply are enforced, he, or rather his company, will be merely one of the possible purveyors. This invention is practically a gift to the working men of the world and their families. The net result will be that those who care to avail themselves of the privilege may, sooner or later, forsake the crowded apartment or tenement, and be comfortably housed in sanitary, substantial, and roomy homes fitted with modern conveniences, and beautified by artistic decorations, with no outlay for insurance or repairs, no dread of fire, and all at a rental which Edison believes will be not more, but probably less than, $10 per month in any city of the United States. While his achievement in its present status will bring about substantial and immediate benefits to wage earners, his thoughts have already traveled some years ahead in the formation of a still further beneficial project, looking toward the individual ownership of these houses on a basis startling in its practical possibilities. End of chapter 20. Recording by Melissa.